ወደ ዛሬው እንትናችን ንግባና ኢንትሮዳክሽን ሰርኪዩት ኤሌመንትስ ምንድን ናቸው? ሰርኪዩት ኤሌመንት የሚባሉት ሰርኪዩት ኤሌመንት What are circuit elements? Circuit variables. What are circuit variables? What are circuit elements? Right, master ይጠበቅብናል. Elements can be classified as passive and active elements, and active elements can generate electricity, and passive elements consume or uses electricity. So before identifying the type of elements, we classify elements by two categories. These two categories are passive elements and active elements. So an active element is capable of generating energy, while passive elements consumes, not generating energy. So a typical active element includes generator, batteries, and operational amplifiers. And the most important active elements are voltage or current sources. That generally deliver power to the circuit, to the connector, to them. So for the passive elements, the three elements are passive elements: resistors, capacitors, and inductors. What's the difference between resistance and resistor? Capacitance and capacitor. Inductance and inductor. What's the difference? ሌላ So there are two kinds of sources. The most important active elements are voltage or current sources. So that sources can be classified as independent and dependent sources. Independent sources are sources that are not dependent on other sources. Independent sources are, as the name indicates, it depends on other sources. So another independent source is an active element. Look, an active element that provides a specified voltage or current that is completely independent of other circuit variables. ከሌሎች circuit variables ጋር ምንም አይነት ግንኙነት የሌለው ነው። ዲፔንደንት ጥገኛ እንደማለት ነው። ኢንዲፔንደንት ደግሞ ራሱን ችሎ ሊቆም የሚችል So an ideal independent voltage source delivers to the circuit whatever current is necessary to maintain its terminal voltage. its terminal voltage. So physical sources such as batteries and generators may be regarded as approximation to ideal voltage sources. Ideal voltage sources battery in the storage እንጠቀምበታለን ማለት ነው። Look, እዚህ ጋር voltage sources can be AC or DC. They are independent sources. Dependent sources እንትኑ ራሱ ይለያል። ዲያመንድ ቅርጽ ነው ያለው። ዲፔንደንት ያ ማለት በሌላኛው ሶርስ ላይ ዲፔንድ ነው የሚሆን ማለት ነው። አንደኛው ሌላኛውን ኮንትሮል የሚያደርግ so an ideal independent current source is an active element that provides a specified current completely independent of voltage across the source. Yeah, it's current source. So that is the current source that delivers to the circuit whatever voltage necessary to maintain the design designated current. Designated current. So the ideal current source or independent sources. Controlled source is an active element in which the source quantity is controlled by another voltage or current. Another current source, voltage source. እነዚህ ሶርሶች አሉ ዜን ይሄ በቮልቴጅ ኮንትሮል ሊደረግ ይችላል። ይሄ በከረንት ኮንትሮል ሊደረግ ይችላል። በከረንት በቮልቴጅ ከረንት ኮንትሮል ሊደረግ ይችላል። አንደኛው በሌላኛው ማለት ነው። ለምሳሌ ከረንት ሶርስ ካለን ቮልቴጅ ኮንትሮል ሊሆን ይችላል ኦር ከረንት ኮንትሮል ሊሆን ይችላል። ዲፔንደንት ከሆነ ማለት ነው። ቮልቴጁ ደግሞ ከረንት ኮንትሮል ሊሆን ይችላል ወይም ደግሞ ቮልቴጅ ኮንትሮል ሊሆን ይችላል። ዲፔንደንት sources are sources that depends on the other source in the circuit. So the dependent sources are usually designated by diamond shaped symbol like this. በእነዚህ መንገድ ሲምቦላይዝ ይደረጋሉ ማለት ነው በእነዚህ So the control of the dependent source is achieved by the voltage or current of some other elements in the circuit. And the source can be voltage or current. Voltageaችን ሶርሳችን voltage ወይም current ሊሆን ይችላል. It allows that there are four possible types of dependent sources. ስላችሁ የነበረው ማለት voltage control, voltage source or voltage control current source. ሌላኛው ደግሞ current control voltage source እና current control current source. Current control current source, current control voltage source, voltage control current source, voltage control voltage source. Sir, dependent source አንደኛው በሌላኛው ላይ ዲፔንድ የሚሆነው ማለት ነው። ለምሳሌ እዚህ ጋር እንደምታዩት ይሄ ቮልቴጅ ሶርስ በከረንት ሶርስ ኮንትሮል ሊደረግ ይችላል። ልክ በእነዚህ ሪሌሽን ማለት ነው። ወደ ኤሌመንቱ ስንመጣ resistor, the material in general have a characteristic behavior of resisting the flow of electric charge. This physical property is ability to resist a current which is known as resistance and is represented by a symbol R. So the resistance of any material with a uniform cross-sectional area depends on area, length, and resistivity of the material. Which is rho over A. As the length increases, the resistance increases. As the resistivity of the material, conducting material increases, the resistance increases. Since resistivity and resistance are directly related. And when the cross-sectional area of the conductor increases, the resistance decreases, which are inversely related. So the circuit element used to model the current resisting behavior of a material is the resistor. Circuit element used to model the current resisting behavior of a material is a resistor. ስለ resistor ካወራን ደግሞ there is a scientist whose name is Ohm. ከዚህ ጋር ሪሌት የሚያደርገን ደግሞ ሌላ አዲስ ጋር ማለት ነው። Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through it. V directly related to the current. And R is the proportional constant. V is equal to I times R. This is Ohm's proportional constant R resistance. Ohm's defines the constant of proportionality for a resistance to be resistance R. So the resistance is a material property which can change if the internal or external condition of the elements are changed or altered. Example, if there is a change in temperature. Changing in temperature. It depends on external or internal characteristics or conditions. So the resistance R of an element denotes R, which is R is equal to V over I, which is measured by ohm, and 1 ohm is equal to 1 volt over 1 ampere. 1 volt over 1 ampere. 1 ampere. There are two conditions in this case. There is two conditions in this case. There may be the resistance infinity or there may be the resistance 0. If the resistance is infinity, the circuit is said to be open circuit. And if the resistance is 0, the circuit is said to be short circuit. Short circuit. Look this one. A short circuit is a circuit element with the resistance approximately 0. Approximately 0. Therefore, the voltage in the short circuit is equal to 0 since the resistance value is 0. And the open circuit, an open circuit is a circuit element with the resistance approaching infinity, and the current in the open circuit is 0 since resistance is infinity. Since resistance is infinity. What about conductance? The reciprocal of the resistance. The resistance is the ability to resist or to oppose the flow of current. What about conductance? The ability to conduct. To conduct. The ability to an element to conduct electric current. And it's measured by Siemens. Siemens. Or inverted ohm. So the power P is equal to potential difference V times the current passing through the circuit, and V is equal to IR. P is equal to VI ሁለት አይነት ሪሌሽን አለ። V IR I V over R እዚህ ጋር ስንተካውን ይመጣል V square over R አይደል? What about this one? እዚህ ጋር ተኩና አይት I square R. P is equal to I square R. This is V ማለት IR ነው። What about I square? አው እንዲህ አይነት ጥያቄዎች ሊኖሩ ይችላሉ። እንትን ያለ ቀለል ያለ ዝም ብሎ በቀላሉ ሊመለስ የሚችል ሊታወስ የሚችል ማለት ነው። እነዚህ ቤዚክ ሎስ የሚባሉት እነዚህ ቀለል እንትኖች ናቸው። ማስታወስ ያስፈልጋል። ልክ ቅድም ዋኔዝ ብዬ የጠየቁት ጥያቄ አለ እንደዚህ አይነት ጥያቄዎች ማለት ነው። ወይም ደግሞ ምን አይነት ጥያቄ ይወጣል ብላችሁ ካሰባችሁ ወደ ኋላ 12ኛ ክፍል የተፈተናችሁትን እንትን አስታውሱ። ጥያቄ 12ኛ ክፍል የተፈተናችሁትን ጥያቄ ስታስታውሱት ምርጫው በምን አይነት መንገድ ሊወጣ ይችላል የሚለውን ነገር እሱ ራሱ ሊመልስላችሁ ይችላል። ፊዚክስን እዩት፣ ኬሚስትሪን እዩት፣ እነሱን ብታያቸው ልክ ከዚህ ከቴክኖሎጂው ጋር ቀጥታ እንትን ሊገናኙ ይችላል። ማትማቲክስን እዩት። የማትማቲክስ አሁን ምርጫ ነው አለ 14ኛ ክፍል ማትማቲክስ ምርጫ አስቡት ምን ሊመስል እንደሚችል ማለት ነው። ልክ የእናንተንም ከዛኛው ጋር ማገናኘት ማለት ነው። እንደዚህ ይሆናል ብሎ ማሰብ እነዚህ ኮመን ስለሆኑ ማለት ነው። we should note that a power dissipated in a resistor is a nonlinear function of either current or voltage. Nonlinear function. Since the resistance and conductance are positive quantities, the power dissipated in a resistor is always positive. A resistor always absorbs power from the circuit. It absorbs. This confirms that the idea a resistor is a passive element incapable of generating energy. The other element is capacitor. It's a passive element designed to store energy in its electric field. It's used as storage of energy. Besides a resistor, capacitors are the most common electrical components. Most common in electrical components. Capacitors used extensively in most of electronics, all electronics ማለት እንችላለን communication system, computer and power systems. all የማይገባበት ቦታ ላይ ታገኙ ትችላላችሁ። For example, they are used in tuning circuit of radio receivers and the dynamic mode element in computer system. Dynamic computer element. So a capacitor is typically conductor as dielectric with permittivity and metal plates በዚህ መልኩ ማለት ነው። በቮልቴጅ ሶርስ ኮኔክት ስናደርገው ቻርጅስ ፖዚቲቭ በፖዚቲቭ ኔጌቲቭ በኔጌቲቭ ቻርጅ ያደርጋል ማለት ነው። ቻርጅስ distance d the distance between the plates positive plate and negative plate ማለት ነው። So a capacitor consists of two conducting plates separated by insulator or dielectric. In many practical applications, the plates may be aluminum foil, while the dielectric may be air, ceramic, paper, or mica. በመካከል ያለው ማለት insulating. When a voltage source is connected to the capacitor, as the source deposits in positive or negative charge. So the capacitor is said to be store energy. And the amount of charge stored represented by Q is directly proportional to the applied voltage. Q is equal to C times the voltage V. The voltage V. So the unit of the capacitance Farad is the honor of the English physicist Michael Faraday. The capacitance is the ratio of the charge on one plate of a capacitor to the voltage difference between two plates. 1 farad is equal to 1 coulomb per volt ማለት per volt. Although the capacitance of the capacitor is the ratio of the charge Q per plate to the applied voltage V, it does not depend on Q and V. ለምን ነው ዲፔንድ የማይሆን? The formula shows the charge is equal to the multiplication of the capacitance times the voltage. C constant. It depends on the physical dimension of the capacitor. C is equal to permittivity of the conductor times area divided by the distance between the plates. Area increases, capacitance increases. Since its storage is more as the area increases. If the distance between the plates increases, it decreases the charge. The capacitance decreases. The capacitance decreases. So there are three factors. Factor determines the value of the capacitance. the value of the capacitance. የመጀመሪያው surface area of the plate. The larger the area, the greater the capacitance. The larger the area, the greater the capacitance. The spacing between the plates. The smaller the spacing, the greater the capacitance. Spacing በመካከል ያለው spacing ተጠበበ more capacitance ይኖራል ማለት ነው። The other factor is permittivity of the material. The higher the permittivity, the greater the capacitance should be. The capacitance should be. So capacitors are commercially available in different sizes. Yes, size ነው የሚነግረው picofarad, microfarad. They are described by dielectric materials. They are made of and whether they are fixed or variable type. Fixed or variable type. Q is equal to CV. መቼ ነው ቻርጅ ሆነ የምንለው? ካፓሲተሩ ቻርጅ ሆነ የምንለው መቼ ነው? ወይም ደግሞ ዲስቻርጅ አደረገ የምንለው ማለት ነው። ምን አይነት ዲፈረንስ? እሺ according to the passive sign convention, if the voltage V and current I are greater than 0 or if the voltage and current less than 0, the capacitor is being charged. That means the multiplication of the voltage and the current should be positive. V times I should be positive. If either of the two becomes negative, the capacitance discharges. The capacitor discharges. Look this relation. Current is the time rate of charge and Q is the multiplication of the capacitance times the voltage. I is equal to dq by dt and Q is equal to CV. Then derivation እናደርገው ምን ይሆናል? derivate አድርገን ማለት ነው። Then d by dt of CV. Since this is constant, C dV by dt. Substitute this in this place. Therefore, ምን ይመጣል እዚህ ጋር? The voltage V is equal to the voltage V, this one. Current I is equal to dq by dt, which is what about Q? Q is equal to C dV by dt. This dq is C dV by dt. Then V is equal to I times dt is equal to C dV divided by C. then 1 over c I dt is equal to c dv. Integrate both sides. 1 over c minus infinity to some time t c dt is equal to the capacitance value c. And so the instantaneous power delivered to the capacitor is equal to the multiplication of voltage and current. Since V is equal to 1 over c, the integral of t naught up to t I dt plus v naught, then substitute there. The energy stored in the capacitor therefore is equal to 1 over 2 cv square. cv square derivation ስሯቸው ቀለል ያለ ስለሆነ ማለት ነው። There are important properties of capacitor. The first one is a capacitor is an open circuit to DC. Don't forget. A capacitor is an open circuit to DC. If a battery DC voltage is connected to it, it charges. The voltage in the capacitor must be continuous. So the voltage on a capacitor cannot change promptly or shortly. The next important property is the ideal capacitor does not dissipate energy. Ideal, not practical. That's the real or non-ideal capacitor has a parallel mode of linkage resistance. Calculate the charge stored in a 3 picofarad capacitor with 20 volt across it and find the energy stored in the capacitor. This is the answer. Since the charge Q is equal to the multiplication of the capacitance times the voltage, which is 60 picofarad, and the energy stored in the capacitor is equal to half times C times V square, which is 600 picojoule. What about this? The voltage across a 5 microfarad capacitor is V of t is equal to 10 times cosine of 6000 voltage. Calculate a current through it. So by definition, a current is equal to the capacitance times the derivation of the voltage. With respect to time, which is minus 0.3 sine of 6000 ampere. There are connections for the 3 elements: inductor, capacitor, resistor. Series connection and parallel connection. Rather, there are another connections, either of the two. Neither series nor parallel. It is neither of the two. In order to obtain the equivalent capacitance of n capacitor in parallel, we use Kirchhoff's current law. The current entering the node is equal to the current leaving the node. I is equal to I1 plus I2 plus I3 plus IN, which is connected in parallel. Therefore, the current I is equal to C times the derivation of the voltage. Then we take the equivalent capacitance in parallel connection is equal to the sum of the individual. What about the series one? The sum of the reciprocal. In a register, series connected registers are calculated as What about parallel? Therefore, የሬዚስተር እና የካፓሲተር ካልኩሌሽን ስሰራ ሪሲፕሮካሉ መያዝ if two equal magnitude capacitors are connected in series, what will be the equivalent? What will be the equivalent capacitance? Look, we have 4 pico farad capacitor, 2 4 pico farad capacitor. What will be the equivalent resistance? Which is connected in series? ከነበረበት በግማሽ ከመሳነስ ከነበረበት ከግማሽ ያ ማለት አራት ከነበር ሁለት ይሆናል ማለት ነው። ኢኳሊቲ እንዲህ አይነት ጥያቄዎች ብዙ ጊዜ እንትን ሶስት ቢሆን ሶስት ቢሆን አራት ስልሳ ሲካፈል በ12 አራት 16 ሲባዛ በአራት ነው ሲካፈል 12 ይመጣል። እንዲህ አይነት ጥያቄዎች ይኖራሉ። ብለዋል እንደዚህ ጥያቄ ሲወጣ መካከለኛ፣ ጠንከር ያለ፣ ደካማ ሶስቱንም ያማከለ እንትን ይኖራል ጥያቄ። ጠንከር ያለ ይሆናል ለመለያ ተብሎ ስለሚወጣ ጥያቄ ማለት ነው። እንዲህ አይነት ጥያቄዎች ኮመን ናቸው ብዙ ጊዜ። So the equivalent capacitance of series connected capacitor is the reciprocal of the sum of the reciprocals of the individual capacitors. Look, nice connection is got ሁለቱንም ያዘ ማለት ነው። ሁለቱንም ያዘ። ስለዚህ ከዚህ ነው ጀምሮ የተባለ ዳይሬክሽን ይሰጠናል። ካልኩሌት የምናደርግበት ዳይሬክሽን ይሰጠናል። What about this one? ከዚህ እንጀምራለን። ዜን እዚህ ጋር እንመጣለን ሁለቱን ይሄን እና ፓራላል እንሰራለን። ዜን ከዚህ ጋር ሲሪየስ መጨረሻ ላይ ኢኩቫለንታችን እናገኛለን ማለት ነው። The third element is inductor. An inductor is a passive element designed to store energy like that of capacitor and its magnetic field. So inductors find numerous applications in electronic and power systems. They are used in power supplies, transformers, radios, TVs, the electric motors. Any conductor of electric current has inductive properties and may be regarded as an inductor. But in order to enhance the inductive effect, a practical inductor is usually formed into a cylindrical coil, like this. Cylindrical coil. Induction principle. Transformer እንዴት ነው የሚሰራው? በምን መሰረት there is turns inductive effect አለ ማለት ነው እዛ ጋር if a current were to pass through the inductor it's found that the voltage across the inductor is directly proportional to the time rate of change of current L di by dt I is equal to C dV by dt V is equal to L di by dt so inductance is property whereby an inductor exhibits opposition to the change of current flowing through it measured by Henry. There is important property of inductor. Look, each element have its unique characteristics. Resistance, capacitance, inductance. የራሳቸው የሆነ property አላቸው። እነሱ መያዝ ያስፈልጋል። The voltage across an inductor is zero when the current is constant. ማለት ነው DC current ሲሆን ማለት ነው ዜሮ ካፓሲታንስ ለምንድን ነው የነበረው ኦፕን አይደል thus an inductor is acts as like a short circuit to DC capacitance acts as open circuit this short circuit an important property of inductor is its opposition to the changing current flowing through it so the current through an inductor cannot change instantaneously like the ideal capacitor, the ideal inductor does not dissipate energy, but the practical is not. Practical is not. What about this connection? How to find the equivalent inductance of series and parallel inductors? Inductance L1, L2, L3, Ln. Sum up in series. ከማን ጋር እንትን ይሆናል? The equivalent inductance of a series connecting inductor is the sum of the individual inductance. What about the parallel? ያው ሶስቱን ኤሌመንቶች መያዝ ያስፈልጋል አንዱን ከሳትን ሁሉንም እንደዚህ ስለምንችል ማለት ሁሉንም መያዝ ያስፈልጋል አይከብድም ግን ደግሞ ያወዛግባል so the equivalent inductance of a parallel inductor is the reciprocal of the sum of the reciprocals of individual inductances these are important characteristics of the basic elements VI and IV characteristics energy series parallel at DC እያለ ምን ወስዶ ማለት ነው እስካሁን ስናወራቸው የነበሩት ኤሌመንት ካራክተሪስቲክሳቸውን እዚህ ጋር ተቀምጠዋል resistance equivalent resistance series the sum of the individual look in series the resistance and the inductance the same what about this one in parallel resistance and in series this one ያው ሁሉ ሶስቱንም ሪሌት ማድረግ የሚቻል ማለት ነው ለዛሬው ይበቃል